Hey everyone, welcome back to the Nourished Child podcast. And if you've ever wondered whether the oils in your child's food are helping or harming their health, you're not alone. There's a lot of confusion out there. And today I'm joined by Dr. Martha Belury, a professor at The Ohio State University and an expert in fatty acids and metabolism. She studies how fats like omega-6 and omega-3s impact inflammation and overall health. And she's really skilled at making this science make sense in real life. I'm excited for this conversation because there's so much confusion right now around fats, and she's going to help us sort through it. So, Martha, thanks for coming on the show. It's such an important and misunderstood topic, and I'm super happy that you're here to help us suss out some of this fact from fiction.
My pleasure. Thank you, Jill, for having me.
Tell us a little bit about how you got interested in fat metabolism and researching omega-6s and 3s and all the different fats that we need in our body.
Well, thank you for asking because I think it's a fun story because what we learn in science is often surprising. And when I started out as a doctoral student a couple decades ago, there was a big theory being circulated among scientists that polyunsaturated fatty acids were good for us. We
Mhm.
still think that's true, by the way, and we can get back to that a little later. And that these classes of polyunsaturated fatty acids, the omega-6 polyunsaturated fatty acids and the omega-3s, might have some counter effects to each other. And in fact, at that time, there were a lot of theories saying that omega-6 and omega-3 compete for the same enzymes. So if we want to get some more omega-3 action in our cells, we might want to reduce the omega-6 fatty acids.
Hmm.
Now, I'll say this was 30 years ago. I'll just admit it. And this is when I started my doctoral research. And for 9 publications in my doctoral research, we learned that that story was not that simple.
Wow.
And yeah, it is wow because it taught me a lot about how to publish data when it's against a scientific theory. My mentors were fabulous about teaching me how to do that and how to continue to pursue this story, which we've ended up doing for most of my career in my own
Hmm.
laboratory now.
And you're at the Ohio State. How many studies do you have going on at the same time, and how many people do you have working with you?
My gosh, I have a great laboratory full of graduate students and two staff members who we have a large clinical trial right now where we're looking at how polyunsaturated fat rich oil compared to a monounsaturated fat rich oil could help. We're comparing how they affect older people's skeletal muscle. And our theory, based on data from our lab and many other people's laboratories, is that the polyunsaturated fatty acids, which are mostly in our case omega-6 in this study, could be helpful for skeletal muscle rebuilding through helping with energy metabolism in the muscle. And for
Mm-hmm.
older people, that's a critically important issue because as we get older, our energy metabolism pathways start to kind of slow down.
Mm-hmm.
We become a little more insulin resistant, and that means our skeletal muscles also becoming more insulin resistant. So we think these polyunsaturated fatty acids could be important in restabilizing that metabolism in skeletal muscle.
There's a lot going on with muscle and aging and health. We're actually going to focus on the other end of the spectrum, which is children. We're going to talk about polyunsaturated fatty acids. I've done a lot on this show with DHA and EPA and the omega 3 fatty acids, but I really wanted to focus on omega 6 fatty acids today because I think that there's just a lot of mystery around them. And we're not talking about them so singularly, I feel like, in social media. And so I want to sort of build a base of knowledge for the listeners out there. So let's start very simply and tell us, what are omega-6 fatty acids?
Yeah. Omega-6 fatty acids are a group of polyunsaturated fatty acids that have multiple double bonds. So poly means many. So two or more double bonds in a fatty acid means that fatty acid is polyunsaturated. And what those double bonds do is they give the fat or the oil more liquidness in room temperatures. We can really pretty much rank oils by saturated or unsaturatedness based on how they look at room temperature, or if you even move some into your refrigerator, some will start to cloud up, and that means they have a little more saturated fat in them. We
Mhm.
know some fats, which are mostly saturated, will be solid at room temperature. So basically, the liquidity of the oil could tell you how much unsaturatedness is in the fats. Polyunsaturated fatty acids from omega grouping are referring to a structure where the first double bond is 6 carbons in from the omega end. So it's a very chemical structure kind of reference. Omega
Mhm.
3 fatty acids mean the first double bond is 3 carbons in from the omega end. And so that's the omega 3 or omega 6.
Mhm.
Those differences in those structures tell us a little bit about how each of those fatty acid groups are going to be metabolized, but it turns out they're very parallel in a lot of their metabolic pathways, which was what set up that original theory that I studied when I was a doctoral student, and which I've continued to address in many of my studies. We do look at long chain omega 3 fatty acids and their roles in neuroinflammation, inflammation in general, and
Mhm.
other health effects. And we do see good evidence that those are important. We then also see that omega 6 fatty acids found in different vegetable oils also have very many health benefits, especially in the areas of cardiovascular disease prevention and diabetes prevention.
So, circling back to the saturated solid at room temperature, I mean, butter comes to mind, lard. I'm thinking coconut oil too,
Mm-hmm.
because that can
Yep.
be very, and I think it's important for listeners out there to understand that coconut oil is a saturated fat. And when we're talking liquid, we're talking things like olive oil, soy oil, sunflower, safflower oil,
Yep.
vegetable oils. So,
Yep. Yep.
just to put that out there. Why are omega 6 fatty acids considered essential in the diet?
Well, there's actually one essential fatty acid that's an omega 6 fatty acid, and that's called linoleic acid. The only other essential fatty acid in our human diet is one omega 3 fatty acid called alpha-linolenic acid. So we only require one of each class or group of polyunsaturated fatty acids in our diets. Then our bodies can make the rest of the omega 6 family fatty acids and the rest of the omega 3 family fatty acids. So we can't make those two original or essential fatty acids, and that's what distinguishes them as being required or essential:
Mm-hmm.
linoleic and alpha linolenic acid.
Okay. And so when we think about the role that omega 6s and even linoleic acid plays in the health of children, what are we talking about? Like what is the role?
Mm-hmm.
if
Yeah,
if there if there's this essential fatty acid in omega-6 fats that we cannot get or make on our own,
yep.
what is happens when we don't have it?
Well,
What is a role it's playing?
I mean, the worst case is actual sickness and death, just like if you're missing any essential nutrient that your body needs to make the tissues, literally synthesize your tissues. If you don't have that essential nutrient, you can get sick, you can die. Those cases rarely happen with essential fatty acid deficiency. They have happened in even in experimental animals, where diets were fed to experimental animals where they only get one source for their diet, and if that didn't have the essential fatty acid, they could get sick and die. We've also seen this, unfortunately, in some populations where infants were given infant formula that was missing the essential fatty acid because, and I'm not sure, I didn't go back and look to see if it was because we didn't know at the time that
Mm-hmm.
those fatty acids had to be in there, or if they forgot to put them in. Whatever the case was, unfortunately, it can be literally lead to death.
Mm-hmm.
We don't know how much we actually require for optimal health, but in children, we do know, just like in even adults who are turning over tissues, in children are building tissues and turning over tissues, right? They go to exercise, their muscles are turning over and they need to replenish those muscle tissues. Same with adults, but children then have that added need for nutrients because they're putting new tissues down. That's part of the process of growing. And so, unfortunately, for alpha linolenic and linoleic acid, we don't have RDAs yet. There's about a handful, there's almost 10, I think, nutrients we don't have RDAs yet set for them, which is
Mm-hmm.
hard to believe when I think about, we think we've progressed in nutrition, and then I think back and I think, okay, we got a little homework to do back there. But we do know we do need more of these two essential fatty acids as we grow in size, like most nutrients.
Mm-hmm.
So as you get older and become an adult, then you need probably the most. For children, we know these are important, and because polyunsaturated fatty acids go into all of your cell membranes. So every single cell in your body, your muscle cells, your liver cells, your lung cells, your fat cells, your skin cells, all of those different cells need phospholipids, and phospholipids are composed of polyunsaturated fatty acids primarily. You can put some saturated fatty acids in there too, but they
Hmm.
have to have some polyunsaturated fatty acids.
Yeah, I mean, it seems so obvious that they're very needed. I guess my side question would be, why don't we have an RDA for these? And are
Mm-hmm.
we close to having an RDA for them?
I
What's
have,
the obstacle,
yeah,
I guess? I
the
guess another way to say
obstacle,
that.
it's a great question. And as a nutrition researcher and a scientist in nutrition, I've seen this over the years. And it's that I think sometimes we forget to build the fundamental foundations for things. And it partly could be that there's so many other exciting things to fund in science. I would use the example right now of the microbiome. There's
Hmm.
so much interest in the microbiome. NIH, USDA, these agencies are excited about those areas, and we don't know a lot about the microbiome, for instance. We're still
Hmm.
just at literally the tip of the iceberg. But then we forget to go back and fill in some of our missing pieces because they're not
Hmm.
as exciting. I'll just be blunt. Figuring out an RDA is not sexy.
Yeah.
Studying the microbiome is very popular and sexy. And even
Yeah.
our funding agencies kind of sometimes get swung over to what's new and exciting and shiny. And we forget to do the kind of, well, it's kind of, we got to figure out what we need for minimally need for health and what we maximally need for health and what's going to optimize health through your lifespan and how does it change with men and women and boys undergoing puberty and girls undergoing puberty and then women undergoing menopause. All of these different life stages have to be really clearly characterized. It takes large studies and it takes a lot of money.
And do you think that not having an RDA for these essential nutrients has unintended consequences to our
I
population
I
health?
do. I do because we use RDAs not only for helping each of us use to guide our own dietary choices, but we use them in things like food assistance programs. I'm thinking of the school lunch programs, food assistance for older people, food assistance for SNAP and WIC and other
Hmm.
programs. We also use them as a kind of barometer to make sure we're meeting the needs of our population. For instance, the United States, we want to make sure we have adequate sources of
Hmm.
foods that provide adequate nutrition. And when we don't have a standard, we don't have anything to compare it to. What we use right now are called adequate intake levels. Those are built basically reflecting on what people are eating where we don't see deficiency. Okay, so that's
Hmm.
a little different than looking at what we do need for optimal health. And
Yeah.
so missing an RDA or missing RDAs for our two essential fatty acids, linoleic acid and alpha-linolenic acid, means it's really hard to say if we're getting too little, too much for optimal health.
Hmm.
And that's where I think we kind of start building a house on sand when we're saying people aren't getting enough or too much. Well, we're kind of guesstimating that,
Yeah.
unfortunately.
Yeah. And I actually also think it feeds sort of the misinformation that we're seeing right now when we don't have an established criteria of or a threshold of what we actually need. It sort of allows everybody to speculate and dream about,
What
what is healthy and what's not, and what we need and what we don't need. And I think that's going to.
That is so well said, Jill. I agree with you 100% that some of these very, very basic things then enable other things to kind of, you said it much better than me, but kind of just build up on, again, building a house on sand when we don't
Yeah.
have the basic foundation. We don't have something solid to build onto.
Yeah, yeah. So, and I guess that kind of segues us into this next part of the conversation, which is, what is one of the biggest myths around omega-6 fatty acids that you see out there?
I'm seeing two. I've seen one for a long time, and that is that omega-6 fatty acid intake has increased as industrialized edible oil production grew. So, as edible oil manufacturers learned better and better how to isolate oils from seeds and other vegetable sources using extraction methods and then purify the oils in large quantities, our intake of omega-6 fatty acids has gone up. And omega-3 fatty acids has probably not um, gone up as linearly as omega 6. What people forget is several other things have changed in our food supply, including the fact that we eat more calories in general than we
Mm-hmm.
ever have in the past. On average, I think we eat, I think it's like 400 or 500 calories more. No, it might be a little less than that, 300 calories per day more than we used to eat.
Mm-hmm.
So, and we're not as active. Generally, our occupations, I'm sitting at my desk right now talking with you, and I'm not moving around. I'm sitting. Well, I do fidget a bit, but that's not burning those extra calories. So
Right.
there's a lot, and we're eating less fiber. We're eating more sodium. We're eating more foods that might not be as variety like in terms of color on your plate, if that's one of the ways you measure your variety in your diet, which I tend to use in my own life. So
Mm-hmm.
there's a lot that has changed in our food supply. So that increased level of omega-6 fatty acid intake is one of the things people say, well, that's what's bringing on more obesity and more disease. The more recent thing that I've heard is this idea that seed oils are contributing to diseases and risk for diseases because of their being in processed foods. We're going to, I'm opening up a whole nother term that has really no definition. How
Mm-hmm.
people define processed foods goes all over the spectrum. But I think if you're going to blame an ingredient for something, you should have more data. And I think just saying, well, vegetable oils are in processed foods, and therefore, if people eat more processed foods, they're eating more vegetable oil and they might have a higher risk for disease. There's a lot of assumptions in that whole statement I just said that are, again, undefined. And so then I think they're allowed to be perpetuated because they're not defined. Processed foods, omega 6s. Is every processed food the same?
Right.
What do we decide is harmful and what's not, and how much, and so forth?
And I'm wondering, has anybody ever looked at processed foods and measured the amount of omega 6 in it versus the amount of sugar, the amount of dyes, additives? I mean, really, it's a package.
It's a
It's
package,
the package.
and there are thousands of processed foods. So how do we compare one to the next? It's a very complicated,
Yeah.
much more complex thing to do than what is implied in a statement.
Yeah. Hey, quick pause. If you've been feeling worried about your child's health, their eating habits, or even their body image, especially if they're growing up in a larger body, I see you. A lot of parents I work with are noticing things like overeating, sneaking food, or a drop in confidence, and they don't want to put their child on a diet, but they do want to help. And that's exactly what I teach inside my group program, Raise a Child Who Thrives. We work on the habits that actually matter. Your home environment, feeding dynamics, food balance, sleep, movement, all through a whole child approach. No dieting, no shame, just practical strategies that work. If you want to get on the wait list for the next group, head to thenourishedchild.com/waitlist. Okay, back to the show. At the top of the show, you mentioned inflammation. I think that's one of the things that I'm hearing, seeing on social media, that omega 6s are inflammatory. And there's a lot of inflammatory emotion around omega 6s. Can you speak to that from a scientist or a scientific perspective? What do we know? What is the latest and conclusive evidence that we have at our fingertips about this topic?
Yes. Well, first of all, fatty acids are not inflammatory themselves, regardless of what anybody is talking about. So the idea that omega-6 fatty acids were pro-inflammatory was kind of part of that pathway that I studied again 30 years ago, where we were looking at omega-6 versus omega-3 fatty acids in a mouse model of skin cancer. And we found basically the opposite 30 years ago, that omega-6 fatty acids reduced inflammation in the skin. And what we now see, and I've seen now in many clinical trials, is that when you fortify people's diets with a vegetable oil that's rich in omega-6 fatty acids, you don't see elevated levels of inflammation. What you tend to see is actually lower levels of these markers of systemic inflammation. And these are things like C-reactive protein, interleukin 6, other cytokines that people in the immune world say are pro-inflammatory. So we see lower levels, not higher levels. I think the reason the theory first came up, and the reason we were studying it long ago, was because there are some products of omega-6 fatty acids that can be acutely pro-inflammatory. And these products come from a downstream omega-6 fatty acid called arachidonic acid. That's a metabolite of linoleic acid that then has to get further metabolized to prostaglandins. So we thought, theoretically, okay, that pathway happens, then we get these products called prostaglandins. And that didn't happen the way we thought it should in our mouse model. We then, with that theory, we thought omega-3 fatty acids, which also can be metabolized to other fatty acids downstream that are omega-3s and prostaglandins from the omega-3 family, those could be anti-inflammatory.
Mm-hmm.
And that is true in theory, but what we didn't understand at the time were their pathways are much more complex. The regulation of each step of metabolizing linoleic or alpha-linolenic acid are very tightly regulated in your body. And so if you feed one of those two parent essential fatty acids, you don't necessarily increase all of the things coming down the pathway chain. One of the other things that people tend to confuse, and I see this even in the scientific literature and among my scientists colleagues, is there's different types of inflammation. So when your body needs to heal a cut or a wound, there are some very quick acting hormones. We call these local hormones. Those are prostaglandins. Those come from fatty acids. Those are
Mm-hmm.
swooping in to actually increase vascularization in that area so you get more blood supply to start to heal that wound. That's acute inflammation versus chronic inflammation, which is what we think are more associated with things like chronic disease. Heart disease is associated with chronic disease. Things like elevations, as I said, of IL-6, interleukin 6,
Mm-hmm.
C-reactive protein, other cytokines, and I keep kind of saying that, but there's a large group of those chronic inflammatory markers.
Mm-hmm.
And those are not from fatty acids at all. Those are proteins that are produced from other immune reactions that your body's making. So those are very different. And I think people don't even think about the fact that there's acute inflammatory
Yes.
compounds or molecules and then chronic ones.
Well, and that was going to be a question of mine to you. So I'm so glad you touched on that because I feel like, again, I don't have evidence around this or data, but I do feel like people are very confused about what inflammation is. I think they think it's swelling or bloating. And you hear people on social media saying, I have an anti inflammatory diet and I need to reduce the inflammation in my body, like it's like your body's swelling on the inside or something. And that's not what we're talking about at all. I talk with parents in my private practice who are raising children with larger bodies, and chronic inflammation. Obesity is an inflammatory disease, right? We know that it alters iron metabolism. It can alter, other nutrient metabolisms. That chronic inflammation is associated with what you just said, chronic conditions and
Yeah.
these lab values that we can measure and say, yes, you have inflammation. Inflammation is not a feeling you have in your body.
Right.
Right?
Right.
It's an active metabolic condition, or I don't even know
It
what the
is.
medical term would be for that, but
Yeah. There's a chronic stressor that's causing these chronic inflammatory markers, these proteins that are called cytokines, to increase and stay elevated. And again, those are very different than fatty acid derived prostaglandins, leukotrienes, these compounds that are produced acutely, and you want them to get into that wound and heal the wound, by the way. So you don't want to get rid of inflammation. Even that chronic inflammation that we're talking about when we talk about maybe people with larger bodies that sometimes can have, especially central obesity,
mm-hmm,
those cytokines are being produced for a reason. We don't actually know why they stay elevated in some people. We know if we can see a reduction of some adiposity in the trunk region, we can start to see those things go down. Those chronic inflammatory markers we think are what's really priming the body for being predisposed for things like heart disease, type 2 diabetes. Now we're seeing more, I think, we're seeing it in pediatric populations too, more fatty liver disease.
mm-hmm,
These are conditions that are associated with more chronic inflammation.
mm-hmm. Yeah. So just back to what you said, omega 6s are not inflammatory in and of themselves. And that, I know that, there's been a decent amount of research on cardiovascular disease in adults and omega 6s. And can you speak to that a little bit?
Absolutely. The research in the 1960s, so this is about 70 years ago, was starting to show clinicians and researchers that people who have higher linoleic acid rich oils like vegetable oils in their diets were at lower risk for heart disease. We then started to see the hypothesis coming out that cholesterol was part of what causes atherosclerotic plaques to form, that contributes to the formation of these plaques, which is when the arteries start to get more rigid and closed in structure, right? And then that can lead to a heart attack. Okay, I'm sorry to my cardiovascular friends out there that I'm not a cardiologist, so but that's my kind of, and that's pretty much what happens in baby talk. So we know that cholesterol is part of the process of plaque formation. It contributes to the actual structure. Clinical trials then actually started showing if people who had higher cholesterol levels consumed oils with linoleic acid in them, they could lower their cholesterol levels. And that was a huge finding. So then the American Heart Association came out, I think their first position paper was in the 1960s, stating to prevent heart disease and to prevent especially a secondary event, meaning a second heart attack, men especially, because at that time they were studying only men should consume more vegetable oils to reduce the risk for heart disease. We now know that that same polyunsaturated vegetable oil can lower LDL cholesterol and can even increase HDL cholesterol. So it can have the best benefits for your lipoprotein fractions, the LDL and HDL, as well as total cholesterol. And I think that's been the clearest evidence that suggests vegetable oils can lower risk for heart disease. The way vegetable oils do change cholesterol levels by lowering cholesterol levels is in the liver, and that's basically through cholesterol synthesis.
Now, does this research was in vegetable oils? Does this translate to some of the other plant-based oils that are out there? Sunflower, safflower?
We think any of the vegetable oils and seed oils that are rich in polyunsaturated fatty acids, especially linoleic acid, are going to have this effect. So animal studies have also shown similar effects using different types of vegetable oils. There have not been a lot of clinical trials in women to the same extent that there were in men. I'd love to see some of those funded, but I haven't seen that as much of an emphasis yet. And we also know that linoleic acid has other mechanisms of how it works on metabolism. So it not only maybe affects metabolism of sterols to form cholesterol. So sterols are the precursors for cholesterol. But linoleic acid might also be important in the structural component of membranes to help membranes of some of your cells make energy better. And by that, I mean linoleic acid seems to be very important in mitochondria membranes where ATP is made. And ATP is this energy compound that each of your living cells need all the time to actually produce energy to stay alive. So we're seeing linoleic acid seems to have some other very specific effects that we didn't even think about studying 70 years ago, but are now starting to show more evidence in this area. So I think that's where we're starting to see a link also with reductions in risk for type 2 diabetes and metabolic syndrome.
So for a parent or a pediatric practitioner who might be out there listening to this, I mean, it sounds like seed oils have kind of gotten a bad rap. Plant-based oils have gotten a bad rap and sort of have been miscategorized in terms of their real effects on metabolism, inflammation, chronic disease. Is it fair to say that? Do you feel that way as well? Or is there just a lot of things we still don't know about this?
Well, there's good point. There's a lot of things we don't know about everything in nutrition. And I'll say, I think that's kind of one of the reasons for a long time, some of our national federal agencies have avoided funding nutrition because it's messy. We know food is messy. Food dietary choices are messy. We know what we know is not always what people will do. There's so many things that influence how healthy food can get into a person's body. With that caveat, do I think the seed oil wrap has kind of been I think it's been very misguiding. I will say, just looking at the science, I never wanted to be studying oils 30 years after I started studying oils. I will just say that I would be happy if somebody said, hey, there's another research area you can start studying and what you know something in, which is I study muscles and adipose tissues. And I'd say, okay, you show me the data and there's enough evidence there, I'll go. But for some reason, we keep studying polyunsaturated fatty acids because they keep showing us some unique things that they do in cells, which end up affecting people's bodies. The seed oil thing, it kind of surprised me when it came up. It came up, I think, through a diet book that was authored about maybe 8 or so years ago.
Mm-hmm.
I kind of want to say it seemed to be it was like creating a fear so that the book could then solve the fear. And I see that sometimes in, I would say, misleading nutrition diet books that
Mm-hmm.
you'll see this like a villain identified. And then if you change this by reading my book and you know how to do it, then you'll get rid of the villain that's
Mm-hmm.
causing whatever Y or Z. And I think that's kind of what, when I looked through this book, I sort of started to think it was misleading.
Yeah, yeah. Well, especially it seems to fly in the face of some of the research you've done and some of the research you've summarized here.
Well, and I'll say those sometimes these diet books will have an element of truth. So this book
Mm-hmm.
pointed out we have increased industrialized edible oil production and consumption. We being the free market people,
Mm-hmm.
whatever. It's true. And we've done that in part by changing how we get the oils out of the plants. So we have extraction methods. The book brought up, I think, using hexane, which is a solvent that's an organic solvent that will solubilize lipids and pull them out of aqueous things like leaves or fruits or whatever, seeds. So that's true. But then hexane actually evaporates. That's kind of organic solvents do that. That's part of the point of them is they're not aqueous, so they don't sit at room temperature and not solubilize. Their
Mm-hmm.
boiling point is very low. Anyway, it doesn't matter.
Mm-hmm.
They vaporize quickly. So the hexane doesn't sit with the oil once it's extracted. And so the author was right, and yes, hexanes are used. The author was incorrect to say that those are sitting in the oil you eat. In
Right.
fact, the safety level of what's allowed in food for hexane is much higher than you would see in an edible oil container. I don't even know if you see any in the edible oil container. The other
Mm-mm.
thing about these oils is because they're extracted, other things in the oils are removed,
Mm-hmm.
including things like gums that would make the oil go rancid, and we don't want anybody eating rancid oil. Rancid oil is bad for you. It's
Mm.
true. It's oxidized. It's forming other compounds, things like aldehydes and other compounds that your body doesn't need.
Mm.
And so I would much rather have a fresh oil or an oil that's not broken down with gummy stuff and other stuff and smells literally fishy because it's going rancid. I don't want that in anybody's food supply. So
Yeah.
and we still get antioxidants in the extracted oil. We still do get tocopherols and other things. So I tend to see it from a different lens.
Yeah. Yeah. Of course. I did want to circle back on the omega-6 PUFAs and the research around inflammation and children with overweight or obesity and like what's going on in that arena. I mean, you said, you're finding out so many different roles and impacts around omega fatty acids. I'm wondering if do you know of any research going on in children with obesity or even adults with obesity that might translate down to children in terms of a positive effect on chronic disease or chronic inflammation?
There have been very few randomized control trials, if any, looking at using linoleic acid, again, the main essential fatty acid that's omega-6 fatty acid in vegetable oils, using that in pediatric populations. In fact, I was just on a paper with a group from Europe and other parts of the world where we were writing a review up, meta-analysis on studies in infants and what
Mm-hmm.
infants are consuming and versus what is health outcomes. And there was so little literature, we really had a hard time even writing a review paper on that. So that's in infants. We know very little about how children who are with being overweight or
Mm-hmm.
obese could be influenced by different levels of linoleic acid in their diet. If we can use some of the adult literature and scale it back, and that's not really the proper way to ever do a pediatric study because
Yeah.
children are not little adults, children are children.
Mm-hmm.
But if we could extrapolate from the adult studies, I would say what we see in not older, but adults who have obesity and maybe have metabolic syndrome is we see improved insulin sensitivity when we increase linoleic acid. We see lower levels of CRP and IL. We have just finished a trial it's not published yet, showing that adults with non-alcoholic fatty liver disease who are supplemented with about 2 teaspoons of vegetable oil a day have lower fat in their liver after 16 weeks. So we're seeing these benefits in adults with metabolic syndrome and type 2 diabetes. I would guess we could see the same thing in children, and it's probably through some of the same mechanisms, maybe
Mm-hmm.
through lowering total cholesterol and LDL cholesterol. It also could be through that other pathway that my laboratory and other laboratories are looking at now with mitochondria, where
Mm-hmm.
linoleic acid seems to help the mitochondria work better to make energy for your cells to keep them healthy. But
Mm-hmm.
we're really very early in that mitochondria kind of research, and again, almost no studies in children
Yeah.
yet, but I have
Yet.
hope.
Yes. This is all so great and such an interesting area of nutrition on so many levels. I think as a practitioner who works with families, I'm always talking about swapping out, the fat source from an animal source to a plant based, especially the types of fats that you can add to food, right? And I think it's a very, practical, good approach. It just would be so interesting to know that we're
Yeah.
actually got some concrete data that really is like, this is very helpful in reducing inflammation and delaying that chronic disease pathway. As we sort of wrap this interview up, what, do you want to say to parents out there who might be, struggling with the idea of offering their child seed oils, plant-based oils? I did a YouTube video recently and suggested, all kinds of different oils, and a commenter wrote back and wrote seed oils question mark sad face. And I think that there is a sentiment out there that, parents have a fear about whether these are actually good for their children or not good for their children, and they're confused. I think there's basic confusion about this, and hopefully this interview will clear some of this up. But if you were to give advice or give sort of help parents reframe what they're hearing and what the science says, what would you say to them?
That's a great question, Jill. The things I would go back to are look at the evidence if you can find the evidence. If you don't know how to clear out a lot of information from the evidence, talk to a healthcare professional who can help you go through the literature.
Mm-hmm.
You, Jill, are a health practitioner, a registered dietitian who works with clients. You can help find some
Mm-hmm.
of the literature that can say, here's a paper. Yes, it might be in adults, it might not be in children, but again, actually, by the way, if we're feeding our children healthy foods, we want to be modeling that too and
Mm-hmm.
reducing our own risk for heart disease, diabetes, metabolic syndrome, et cetera. But reach out for help because there is so much information out there. And when I hear you getting that post from one of your viewers of your YouTube, I think it's no wonder. There's so much information, and influencers are megaphones. Many are influencers have the right spirit in looking for the data, looking for the evidence, looking for years and years and years of evidence coming from studies all over the world. I
Mm-hmm.
saw something about seed oils where it was saying the American Heart Association is promoting seed oils because they got funding from the seed oil people. And I'm like, but that doesn't explain why Denmark is also showing that vegetable oils are better for lowering heart disease risk and diabetes. It doesn't explain the studies in Japan. It doesn't. So, bringing all of those things together, though, for a consumer is not easy. I mean,
Right.
let's face it, even reading a package label. It's
Yeah.
not easy some days when you're in the rush and you have children in your cart and you're trying to get through the line and you got to
Yeah.
figure out X, Y, and Z. So reach out, reach out to people who you think could help you go through, decipher what's going on in the literature versus what's going on in more popular press and media.
Yeah. Thank you for that. I think, yeah. And, follow this show. We try to break down all of this fact and fear and myth and misconceptions and try to make it easier on parents if possible.
And you said the keyword fear is a great motivator for people to think it must be true, especially if you have a
Mm-hmm.
solution to the fear that you've created.
Mm-hmm.
There's a little
Mm-hmm.
formula there, but I'll just stop there.
Yeah. 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 Martha, thanks so much for coming on the show and helping us understand omega-6 fats in such easy to relate to explanations. You're talented at doing that because I know it can be a pretty complex topic. Where can people find your work? if they want to connect with you?
I am on LinkedIn. I don't put a lot of my work up there, but I am at the Ohio State University Department of Food Science and Technology. There is a
Mm-hmm.
website there for my department, and I'm linked. My link is in there. Some of
Mm-hmm.
my literature's in there. And in my literature, I, of course, cite these other papers from all over the world. So that's a place to start.
Awesome. Thanks so much for all the work that you do on behalf of all of us, really. And it's been a joy to have you here.
My pleasure. And thank you for being a wonderful communicator about science and nutrition.
Thanks.
Thanks for listening to the Nourished Child Podcast, where the #1 goal is to help you grow a nourished child inside and out.